Hello again, this is Math 1120 remote delivery for April 14th, and this is part 3 of 3. Here we address something that's covered in the book but not in any of the videos that we looked at yet. It's called contingency tables, and this is an example of a contingency table from your book. And since it's called a contingency table, that means it depends, and there's a two-way table because it relates two categories of data. This is the employment status, and that's the level of education. The row variable is the employment status, and the column variable is the level of education. Each box inside the table is called a cell. A marginal distribution of a variable is a frequency or relative frequency distribution of either the row or column variable in a contingency table. And the reason they're called marginal distributions is because they appear in the right and bottom margins of the table. A marginal distribution removes the effect of either the row variable or the column variable in the contingency table. We also talk about doing frequency versus relative frequency. Relative frequency is we're removing the factor of how many people were from each category were sampled, and we're getting percentages. Relative frequencies must be used because there are different numbers of observations for each category. Let's do an example to help us understand these concepts. So here they talked to people and figured out, well, how do you feel about abortion? So here are some opinions, and here are the education levels. So the first thing we're being asked to do is construct a frequency marginal distribution. So what we're going to do is we're going to sum the rows and columns. So here we're summing the columns. Here we're summing the rows. So you see this allows us to have frequencies of the various categories that we have across all the rows or all the columns. Note that the grand total is 833. The next question that's asked is we're asked to construct a relative frequency marginal distribution. Now here what we need to do is we need to take these and divide these all by 833 and divide all these totals that we had before by 833, and this shows us the relative things that happen, whether there are a large number of data points or not. This tells us the fraction or the proportion. That is a relative frequency marginal distribution. The next question is, what proportion of college graduates feel that abortion should never be permitted? Well, in college graduates, that means never permitted. It's 17 out of the total number of college graduates that we have. And so we can figure that out using this, and so we know the total number of college graduates that feel that it should never be permitted should be 6%. Again, we're dividing these by the total number of college graduates. Construct a conditional distribution, feelings based on abortion by level of education, and draw and that's the chart I just showed you. But then what I'm going to do is draw a bar graph representing that conditional distribution. Here's the bar graph. Again, you can see 6% over here was the answer that we had for college graduates. We do have other problems to try, and some of these are regression problems, and some of these are contingency tables. Here is a regression equation to work on. Here is, this is the one we actually did, and the other one, don't worry about that. Here is another regression problem dealing with the weight of a car versus miles per gallon. Here is a contingency table to do. And here is another regression problem. So please give some of those a go or more in your book. Now more than ever, time is precious. Each day must count. Do the math. It will make you strong. Take care of yourself and each other.